Hi everyone, my name is Bhartich and in this video we will be discussing about convergence of sequence. Before going through the video, we will be talking about what is the meaning of convergence. In simple language, if you see, convergence means to tend to a particular point or trying to meet to a particular point. If I try to make you understand by showing this diagram, you can easily understand what is the meaning of convergence. Look at this graph very clearly. I have made a straight line with the green color and one other graph of a red color. If you look carefully, you can clearly state that the red color graph is converging to a particular point on the green graph. As I have already said you, the meaning of conversion is to tending to a particular point or approaching to a particular point or touching a particular point. In this diagram, you can clearly see that the red color one is approaching to a particular point on the green color line. Let us mark this particular point to be L. As we have discussed for this graph can be considered as the sequence Sn. So, suppose if we get the value of S1 by putting the value of n is equal to 1, somewhere we get this value as S1. Similarly, if we put 2, we can get S2. 3, we can get S3. So on and on you can say that the sequence can make a particular graph, and convergence means that it is trying to touch a particular point or tending towards a particular point when your n is tending towards infinity. Now, if this value, these are the value of n, and if it is tending towards infinity, the whole sequence is trying to touch or approach to a particular value, that is L. And this L can be said to be as the limit point of this whole sequence Sn. If we want to learn about the definition of convergence of a sequence Sn is said to be convergent to real L if for each epsilon greater than 0, we'll be discussing what epsilon is, if for each epsilon greater than 0, there exists m, a positive integer, such that here suppose this is the particular value m, what we were talking about, the distance between all the points which is lying after m and L is lesser than the epsilon that we have considered, then we can say that the whole sequence is converging towards L. Suppose now after m what it can lie? It can come as m plus 1, because at m1 m plus 1 sm plus 1 will give the value, at m plus 2 as m plus 2, and particularly there will be an Sn where the value will be Sn, and then Sn plus 1. So what you are seeing that after a value of m, whatever the value of the sequence will be there, the distance between those sequence and the limit point will be extremely small, and that small value is considered to be epsilon. Now, if you write down mathematically, what you can say that Sn minus L, the distance between Sn and L, why we have put mod here? Because distance cannot be negative. That's why we have put mod here, is always lesser than the epsilon that we have chosen. Now, this is true for all the values where n is greater or equal to m. So this is the definition for a convergence of sequence. A sequence Sn is said to be convergent to a real L if for each epsilon greater than 0, there exists positive integer n such that the distance between the Sn and L is less than epsilon, and that is for all n greater or equal to m. If n tends to infinity, you can see that n is approaching towards the infinity, then the whole Sn value is approaching towards L. So we can say when n tends to infinity, Sn tends to L. Or we can say that limit n tends to infinity, then the value of Sn is equal to L. This is important. Now the definition ensures that there are few points that we have to keep in our head, that from some stage onwards, that what is the particular stage, this is the particular stage, that when we reach to a particular value m, we will be seeing that now from here the distance between Sn and L can be made less than any pre-assigned positive number epsilon, however small. That is for any positive real epsilon, no matter however small, there will exist such number m that we consider the mod of Sn minus L will be always lesser than epsilon. This is the first thing that we can assure. The second thing is that now, as I have said you, look at this equation. This equation is important when we are talking about the convergence of a sequence. Now, let us write down this and let's understand that what it is trying to explain you or what you can deduce other meaning from that. Now, as we know that if a sequence is convergent and it is converging to L, and we have this definition that for epsilon greater than 0, Sn minus L is less than epsilon, and that is for all the value n greater or equal to m. If you open this modulus, you will obtain this equation that this whole value is lying between minus epsilon and epsilon. Thus, we can write down or we can simplify this equation to. Now, one thing you must notice that there exist infinite values of Sn that is lying between L minus epsilon and L plus epsilon. Because one thing to notice, you can easily count m is also a natural number. Counting from 1 to m, it will give you a finite set, but from m to infinity onwards, what it is going to give you? It is going to give you an infinite set. So, what is the meaning of that? That there exist infinite terms of Sn which lies between these two ranges. And the second question happens that what if a finite number of Sn lies between these, then what will happen? If finite number will only lie between these, then you can say that Sn may not converge towards L. So for converging to a particular point, you require infinite set or infinite number of terms which is lying between these two ranges. If we want to plot this same on the number line, what we can say that if this is my number line, I know that L minus epsilon and L plus epsilon is going to be a real number. Let's plot these numbers. So definitely this will be lying at the left hand side because it is a smaller number, L minus epsilon, and this will be L plus epsilon. And Sn is sitting between them. If infinite number of terms of the sequence lies here, then what we can say is that finite terms lies outside these intervals. From outside this, from here to here, finite set will be lying. From here to here, the finite terms will be lying. So infinite terms between this and finite terms outside this interval. Then only we can say that the whole sequence is converging to a particular point, that is L. Let us discuss some important theorem related to convergence of sequence. Our first theorem is that every convergent sequence is bounded. So we have to prove that if we have a convergent sequence, it will be bounded. And if you recall the previous video, what is the meaning of bounded? It means that you have a particular maximum value and minimum value such that your sequence is bounded. You must have a capital K, you must have a small k which satisfy this whole equation. Now, let us consider a sequence Sn. Let us consider a sequence Sn converging to a limit point L. We have considered a convergent sequence and it is converging to a limit point L. And if you do recall the definition of convergent sequence, we always have an epsilon greater than 0. For epsilon greater than 0, there exists m a positive integer such that mod of Sn minus L is lesser than epsilon, and that is for all n greater or equal to m. Now you can also rewrite this one as L minus epsilon lesser than Sn and Sn lesser than L plus epsilon. If you do not know what's the meaning of mod or how to open mod, it says that if suppose mod x is lesser than a, it means that x lies between a and minus a. This is the meaning of mod x lesser than a. Simultaneously, we have used the same thing here. And if you open this one, it will something look like this. Minus epsilon will be lesser than Sn minus L. And Sn minus L will be lesser than epsilon. If you send this L here, this will be L minus epsilon lesser than Sn. And this L here, L plus epsilon. Now this with one time this equation will be followed from here to here. First equation will be from can be chosen for this inequality and the next one can be chosen for this inequality. So please do not confuse. They both have been written on the same equation. This may create confusion. So to remove the confusion, I have made you understand this point. Now, as you know that our task is to find that small k and capital K. Now look here. As I have said you that let's recall the graph that we were talking about. And if you remember, I said that I have made a particular graph like this. And you know that they take the values for particular, suppose we have got here 1, so we have S1 somewhere here, and if we have 2 we have got S2 somewhere here, if we have 3 we have S3 here, and in this way S4 we have got S4 here, and it continues somewhere. And so according to the definition, what we can see that if suppose this is my particular value m and this is somewhere the Sn is increasing and it is going to a particular value L, so what I can say that from here this particular value to this particular value, this Sn is lying. It means that it is lying between L minus epsilon to L plus epsilon. Clear? Now let us consider a value. Let us consider this k value which is minimum of S1, minimum of L minus epsilon, S1, S2, S3, dot 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 Sm minus 1. Why? Because we are interested in finding out the lowest of this. हमें इनमें से एक छोटे वैल्यू को निकालना है. For that we can say that the sequence is bounded below. So for that you have to find out that what can be the minimum value from here to here. and definitely you will be getting a real number k. Now let's find out capital K, which is going to be the maximum value of this same set. That is maximum of L plus epsilon S1, S2, S3 and dot Sm minus 1. And this K is again going to be a real number. That's why, and definitely from this one real number can be obtained, which will be in this, which will be bounding this sequence from above. So what we can have, that we will have G, which is lesser or equal to Sn. It may be from this set, that's why equal to sign has been given, and it can be this one, so that's why lesser sign has been also provided, or Sn can be lesser or equal to capital G for all n. Hence what we can say, hence Sn is bounded. Now let's see that whether the converse of this is true or not. Now, as we have explained from one way that every convergence sequence is going to be bounded, we will be checking that whether all the bounded sequence will be convergent. Now let's take one example and let's understand if this is going to be true or not. So we are going to check the converse of the theorem now. Check whether the converse of the theorem is true or not. We will be considering a bounded sequence and we will be checking that whether that bounded sequence is convergent or not. So we will be taking a very simple example, that is sequence Sn is equal to minus 1 to the power n. You can clearly see that this is a bounded sequence because its range is bounded. Now, according to the definition, we will be choosing an epsilon which is greater than 0. So let us consider that, let us consider epsilon to be equal to 1, which is obviously greater than 0, and there exists n, a positive integer such that Sn minus L is less than 1 for all n greater than n. So that is, we can write down that mod of S2n minus L, where we have considered that L is the limit of this equation, L is the limit, is less than epsilon, and S2n minus L is less than epsilon. Now S2m here is going to give you the value as 1 minus epsilon, which is lesser than 1 minus L less than epsilon, and this is going to give you minus 1 minus L lesser than epsilon. Now look here, this can be considered as equation 1, this can be considered as equation 2. Adding equation 1 and 2, what we are going to get, mod of 1 minus L plus minus 1 minus L is lesser than, this can be written as mod 1 minus L plus mod 1 plus L, because according to the identity we know that mod x is equal to mod minus x. So from here the minus has been taken out, and that's why this can be written as 1 plus L lesser than 2 epsilon. But recall triangle inequality. What does it say? That mod of A plus B is always lesser than mod of A plus mod of B. This is the triangle inequality. Applying here, it means that this whole value will be always greater than, if this can be considered as A and this can be considered as B, so we can write down that mod 1 minus L plus 1 plus L will be always less than 1 minus L plus 1 plus L, which is lesser than, let's substitute the value of epsilon, that is was taken as 1, so it is always lesser than 2. Now if you simplify this one, this L gets cancelled, here it is 2 and lesser than 1 minus L plus 1 plus L less than 2. What we get, the result is that 2 less than 2. And this result is not true. This is absurd. And that's why stating that the bounded sequence was convergence is not true. That's why all the bounded sequence is not convergent. The converse of the theorem is not. This also gives rise to one another theorem which states that a sequence cannot converge to more than one limit. And if it is converging to more than one limit, we can say that it is not a conversion. In our next class, we will be seeing another theorems regarding